Okay, good morning. Hello, everyone. Let's wait for another 1 minute to set up your computer and open your R and R Studio, open your Blackboard. Okay, so today's class, let's continue to on our module 2. We're gave some examples in the R Studio software to practice some very basic commands. And those commands and the functions will be very relevant to our machine learning area. All right, and I have us uploaded lab 1, lab 2. This is basically two cases, right? The file script, and when you open that, you need to firstly download on your computer your course folder, and when you open the R Studio, you open that. All right, and today I just upload a data file in the CSV format, which is talk about a student loan default, and there's many variables there, and I guess the lab 2 script will use this data file. So you better want to download this also on your computer because I just added it today, right? I'm gonna approximately give you a homework starting from next Monday or this weekend, Sunday. All right, and but officially start on Monday. I'll give you 10 days. The first homework will be some essay question, talk about the module 1, and some very basic practice relevant to the module 2. All right, so this is part of the module 2 because today we probably cannot cover, and I expect you already begin to review the model since Monday, right? This week Monday, because this or basically online class, right? I definitely assume you are reviewing course materials every day by your own self. All right, so just every Friday we just summarize a little bit. All right, so lab 1 here, right? So let me firstly open the lab 1 files there. All right. So for example, let me let me open the R Studio here, right? Hopefully we have already and I'm gonna to firstly click here, right? Make a separate windows there, and let me open file, right? And this, you can see this goes to my own folder file. All right, so which is the now this is for 2 lab 1. So let me open the lab 1. Okay, so let's type out what kind of a code we have here. Now those are very simple, and I definitely expect you to have begin to self-learn by your own self. For example, let's say the first one. All right, so all of the labs are from the online books I give to you on the syllabus. I give you the link, and when you open that, this can be PDF there. All right, so most of them from that book. So that book also separate each chapter as in terms of a lab. Right, so lab 1, lab 2, lab 3. So I use that directly. I'll go to my class. Definitely, I will moderate something, cater to our demand. All right, for example, like this. This one is very simple. All right, very simple. It's basically a calculation, right? When you run them, they give you 1, right? 2 by 0.5 equals 4 negative, and the 5 plus negative 4 equals 1, right? I think those are very basic ones. Let's I quickly review them, right? And like here, log, right? We understand log. Log is gonna be when you take the log, you basically define what is the base and what is the value, right? Like for example, if you want to talk about the log, right? You want 10 base, all right, and you give the value here 10. All right, so of course, in this case, it's going to be 1, right? So basically, we want to calculate what is the index, all right, equals 10. 10 is here, All right, the base is here. All right, we basically want to calculate with the power. And of course, usually people use the natural log. So that means we're going to use log, and it's going to be E, right? 2.7 something, whatever. All right, you want what value you want, and you can get it with the power. All right, so we basically calculate this power. So in RStudio, of course, we also can do this very conveniently. You need to define what is the base, you need to define the x. Now, you probably want to ask why we like this way, like a log. We understand log is a function to compute the log, right? And we need to understand the base. All right, so that means this one is a log of 5 is base 10. All right, so you can, now, this is the kind of format. You need to define what is the value and what is the base. All right, basically, so this is the requirements, the format you have to write down in this format. All right, so when you Google that, when you Google the log RStudio, and definitely Google will come out with you these functions. All right, for example, let me show you how to self-learning. Give a very simple example. All right, so for example, if you Google them and you learn the log R, right? Log R, and they will directly go to rdocuments.org. This is probably the best website to demonstrate what the grammar and what the format when you write these functions here, right? So this is log functions, all right? So, and right, they clearly list out what the format. You need to take the log, x, and the base, right? And for example, you want to calculate the log, and x and base equals something. All right, equals something. So here, base equals to exp1. This is simply means natural log. All right, natural log, because exp1 is similar to the Excel. When you use Excel, exp1 means the natural log to the power of 1. All right, it is e by itself. All right, so that's basically means a natural log. Actually, there is a simple function for natural log. I think just simply ln. All right, so this is, but log is more general format. You can define whatever the base you want, but usually people use natural log, right? Okay, let's go back to our functions here. All right, and of course you can run this, and it is easy and give you results. All right, and so usually if you didn't specify what is the base, that means simply automatically assume it's natural log. All right, so basically if you, there's totally different results. All right, and for finance, usually people will use the natural log, right? Natural log. So you can say natural log basically means ln 5, right? ln is directly natural log, right? So for example, if you run this, oh sorry, maybe I forgot, right? It is, yeah, in the R. Sorry, I may be confused with other software. You directly use the log, and without specify what is the base, then the computer will automatically assume it is natural log. All right, so that's it. Okay, now we get it clear. So ln is sorry, it's my bad, right? Maybe I confused with other software, the grammar here. So log by itself, if you didn't specify anything on the base, it's going to be natural log. All right, and so sometimes you forgot to write down what the base equals to, right? This is kind of a grammar. You need to specify that, right? But sometimes if you forgot, so computer also allow them, but they will give you a warning for this is a log of 10 with base 5. You basically omit base equals 2, right? Such a kind of a language here. You directly write 5. So definitely, actually, this is means, all right? It means simply at the base 5, right? This means you neglect that. All right, and let's talk about the vectors. All right, of vectors. So vectors, let's say x equals to -1.5. This is a single value, right? So this is a vector, but it's only one value. And sometimes we also use to concatenate all the value together. This is to construct another vector. All right, this is a vector, and so the vector is, in the R software, I don't want to complicate your concepts so far. There is many, the ways people to define a collection of numbers or characters or labels. For example, there is vectors like we discussed, right? an example is a C concatenate in the function and they collect all of the number there. And then we could also have a matrix. All right, matrix. A matrix, there's another way to define what is a matrix. You need to define how many rows, how many columns, something like that. You also need to define the list. List is a little bit complex. All right, we will discuss in the future. All right, but vector, right, and a matrix, probably sometimes if you handle with some math topic, it would be talk about that, right? So, and a vector is going to be like the C 1.2, 2, 3, -5, whatever one. And a matrix, there's specified matrix functions there. All right, since we didn't talk here, I will leave it for future talks, right? Usually the output will be like this. All right, 2, 5, 4, 6, something like this. Is a 2 by 2 matrix. All right. All right, so let's go to here. Right, you also can put a function here like log 15. That means the natural log, right, as 15. So this is definitely, there's some value here. So when you run this, that will get directly present what is a y. All right, now when you copy and run here, they give you y equals. It seems that they didn't directly show you the contents of the y, right? Just all of these. You probably want to just simply type y here, and you can see it clearly show the different value in the one line. All right. Okay, and of course you need to, if you want to know what the length of the y is, because there's only 4 elements, so there's going to be 4, right? It's easy. And y plus 4. Now y plus 4 is interesting because y is a vector. When you plus 4, that means each element is plus 4. All right. So for example, here, everything here. All right, everything here. All right. Now, of course, you can specify another vector, which is z equals to concatenate, those numbers. And this one's a log 5. And you want to take the square root, sqrt square root. I think it's very similar to Excel functions. Excel also have very simple function like this, right? The basic arithmetic, the operations here. All right, and because y and z, I think they have the same length. That means 1, 2, 3, 4 elements. So you can basically do plus, minus, multiply to each others. All right. So for example, when you z equals and the y minus z become this. We already calculated the y in the previous step, and the y minus z, that means each elements, 2 elements minus to each others. All right. So that's gonna be like this. We already have a y equals to c like 1, 2, 3, 4. Just for example, right? So we already have a z equals concatenated vector like 2.2567. All right. So in that case, if a y minus z, that means elements by elements minus to each others. All right. Okay. All right, so we'll go quickly to the next. So sometimes you want to select elements from a vector. We use, squared parentheses. That means, for example, y2. This simply means, remember, we have a constructor vector called y, and a y2 simply means I want a second elements. All right, it's also very easy. All right, and concatenate C14. Now let's firstly run this. That simply means I want the first elements and fourth elements. All right. So that means this one. All right. And if you forgot what is a y involved, you can directly type y. All right. So the first one is -1.5, and the fourth one is 6.7. So it's directly here. All right. Now you probably have a question. Why I need to collect them together like this way? Why I not, for example, let's say, directly say why I want a 1 and a 4. All right, how about this? They will give you arrow. In correct number of dimension. Now, what's the reason is that in this format, you basically assume Y is a matrix, and you want to specify the row number 1 and the column number 4. All right, if you want to specify the elements in the matrix, you can do this way because the row 1 and column 4. All right, so that's, for example, if I construct a matrix, all right, and the matrix. So the matrix is say, sorry, it's not very good. The matrix is a 1, 2, 3, 4. All right, 0, 6, 7, 8. Now let's say this is a 2 row, row 1, row 2, and this is a column 1, this is a column 2, column 3, column 4. All right, this is a 4 column. So in this case, if you specify Y, 1, 4, right, bracket them, so that means the first row and the fourth column, that means this number. All right, this number. So now remember, in our case here, Y is a vector, only one dimension. All right, only one dimension. So that's basically means concatenate 1, 2, 3, 4, 6, 5, whatever. All right. If you want the first one and the fourth one, you need to specify like this. All right. So, all right, this is kind of the correct way to list out to select the elements if this is only one dimension. All right, so there's many ways. For example, if you want to select the first of 4 elements, you can use the 1, 2, 3, 4. Of course, in your the concatenate and just select the elements. You also can use the one column 4. That simply assume the 1, 2, 3, 4. All right, 1, 2, 4, and the first 4 elements. And if you want to replace value, remember the Y second value is 99, right? And this is too large. You want to replace with a 4. You simply directly write down this, right? You want to second elements and you want to equals 4. All right. And you want to take the sum, you want to take the mean, you want to take the average. That means you want to sum all together divided by the number of elements so you can calculate what the average value, right? So I believe those are very basic, operation here. All right. And sometimes, there is a want to do some logic operation, right? For example, I remember previously we have defined the vector, which is z, right? Let's see. Z is here. All right, this is z. And firstly, we want to calculate z positive. Sorry, larger or equal to 0. That means non-negative, right? So let's write down this. True, false, true, true, right? Of course, it's positive, negative, positive, positive. This is true. This is basically a logic operation. You want to judge if the non-negative or not. All right. And you want to sum together. Let's say what's the value, because those are true or false. There's not real numbers, but let's sum together. It's equals to 3. All right, because this simply matter how many frequencies, how many times is negative or positive. All right, and if you take the mean value, it's 0.75. It's 0.75 because there is totally, remember, there's a true equals, true means 1. All right, represent 1. False means 0. True 1, true 1. So it's a 3 divided by 4 elements. So it's 0.75. This one just for illustration. Sometimes the true or false can be considered as number 1 or 0. All right, alternatively, but I don't think there's any much real meaning here. It just some kind of give you some practice, get you familiar with those logic operations there. All right. And now, for example, this case, this one's very interesting. Now, I want to specify, want to make sure all the positive number become 0. And how do we do this? All right. So for example, let's rewrite the Z here, right? Those number, there's a positive, negative, positive, positive. Now the question that I want to replace all the positive numbers with 0. All right. So then you can see this. This one, Z larger than equals 0, that simply specify the position, the index of all the values positive. And you take another Z here, simply means what's position. All right. For example, let's say Z, let's decompose that. Z other than equals 0. The position is true, false, true, true, right? That's the position. And if you take the Z, all the positive elements positions. All right. So you can see the function here. The function is here is that I want to get all of the positive values from this vector, all of the positive values. So you firstly need to tell the computer what is the position of those positive values. All right. And then use the Z again to extract out the concrete values corresponding to those positions. So this is the easiest way to do this. All right. Why this is so important? For example, if you have a 1 million data, 1 million, I want you to extract out a list of the vector that all the positive come out. You have a stock return, a table, for example, in the past 100 years. I want all the positive return years, and or months or even days. You can't say name it, point out which day it is, and then it's impossible. So this one line code will be easily to get this. All right. If you have data, right? If a data name and if a positive rather than 0, and right, and then you can get all of the positive returns values. All right, and this one simply means I also want to give the new values to those original positions. You can specify whatever you want here. Or sometimes, let's say here, if it is a double equal sign, that simply means the logic operation is not equal. All right, in though the value is simply want to charge, is Z equals to -10 or not? Now let's firstly write down this. Now all the positive value becomes 0. All right, so let's write down what is Z here. 0, -10, 0, 0. All right, and now you perform the logic operation, single out all of the values equals to -10 exactly. Say false, true, false, false, right? Because it's exactly, but this is the true, -10. The other is 0, 0. Of course, false, false, because they are not equal to 0, because you want to charge if Z equals to 0, -10 or not. All right. Sometimes you want to put the exclamation sign here. All right. So Z equals -10. That simply means that this one simply means not equal to. No. All right. So that means in human language that means all Z don't equal to -10. So you can see this will be where, because if the mathematics is very easy. All right. It just simply means so what you want to do is that you only want all the values not equals to -10. That's it. But unfortunately, in the software, we don't have such a sign. So we basically need to use this exclamation. That means not equal to. All right. All right. So sorry. Let's run this. See, you can say true, false, true, true. It's reversed. It's reversed because we want to charge it is not equal to -10. Of course, 0, 0, 0, they are not equal to 10. So this is true, 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 right? This one is a false because we want to charge not equal to 10, not equal to 10, right? Never to 10. Okay, and you can see the easiest way to do that. You put exclamation sign and equal to. So you put them together, it represents not equal to. I think this one is a more human friendly. All right. All right, perfect. So there's a last part. And I want to introduce another very powerful function we call R norm. All right, this one is to simulate a group of numbers. Now remember, in the statistics, right? For example, like a stock return. A stock return. We can summarize the frequency tables. The frequency. Now it looks like, say, this is the return, right? This is a return, and the return could be 0, means 0 return. This return is 2%, right? 4%. This one is 8%, and even more. All right, here is a -2%, -4%, -8%, and even more, right? So now what's the frequency table looks like in your imagination? Think about this. Frequency. All right, I say frequency. Okay, and let's say this is the sorry, it's already bad. All right, so I guess this is the say 100%. All right, 80%. All right, 70%. Right, this is a frequency. All right, now let's talk about this. In a stock markets, usually your return will probably on daily basis, on average, probably become between 0 and 2%. That's understandable because remember when you investment take a long run investment in the stock market, usually return can get to 10%, right, on average. But if you talk about a daily basis, the return will be very small, only -1, 0.001 or negative whatever. It's a very small number. Your cumulative return over 10 years could be 10%, but your daily return usually will be nearly 0 on average. Right? Some people get surprise returns to 50%, you're particularly for new and risky stuff, but some people suffer a loss. So usually on average 0. So what happens here? So that means, so 0 return on the daily basis, usually 80%. All right, so let's say daily. You need provide frequency. All right, because that's very important thing to talk about the window lines, because if it is 20 years, you put the money in the stock, of course, it cannot be 0 anymore. 20 years definitely will give you positive returns because although it's experienced many business cycle and a down and up, but usually in general, the economy will goes up. So 20 years, 30 years, definitely your pension, you definitely will get positive returns. It can't be 0. If it is 0, why not go to T-bill, investment in the bank deposit? All right, so that's why the stock market usually cumulative giving me 10 or 20% or even double, but on the daily basis will be quite small. So that's when 0 usually is very possible. All right, and 2, of course, the larger positive returns, the larger negative returns, all of the impossible in most of the cases. So we can say that's going to be like this. All right, now if you talk about this shape, it's look like a normal distribution. Normal distribution. All right, but in reality, what the data will looks like. The data probably, I put some dot. This dot is represent the real points. So that means you most likely look at the blue points, right? If you put the real people's data put there could be some very positive, and sometimes even for 4% could be higher chances than the 3%, something like that. There's some fluctuation, right? The general shape. So if you type a perfect normal distribution, will be like the red colors. All right, but the real data sometimes there's a deviate. All right, so in this case, you probably want to simulate the data. Simulate simply means fake data. The fake data, I want to generate, say 100 days or 100 years stock return data, exactly follow the normal distribution curve. All right, that means I want to I just erase out all of the real data. Let's talk about the fake data. That means this is a perfect normal distribution. All right, and I want to randomly get some points as my fake data. I want to simulate some scenarios. So in this case, I probably want to this points, this points, this points, this points, this points, this points. Anyway, so 100 points randomly, right? That means points could be here, could be there, whatever. All right, it's randomly. So that's so-called a normal distribution. Now, that means I want to generate points exactly follow the normal distribution, but normal distribution, there's some parameters. The parameters will govern the shape because now sometimes the normal distribution is different. For example, this is one way. All right, there could be the other way. Like say, like this is more spiked, or there could be like this is a more lower and a more variation, more larger spread. All right, so all of the shape will govern by the two parameters. One is the mean, usually inserted, we call the mean. This means the mean value. All right, mean value simply means that you're in the middle, and sometimes in a sigma, the so-called standard deviation. Standard deviation will govern the spread out, how the spread out it is, right? If you give the two parameters, you can let the computer to generate a bunch of the data points exactly on a normal distribution. But this is a fake ones. But we still want to research on some normal distribution data, what can give you results in the future, right? So in this case, I first want to generate a fake data and exactly follow normal distribution and do some research there, right? You first need to get data points. So that's what are the function here. Now, say that means R norm. It's very easy, and you give the I want to get the 4 points. All right, and remember the curve. You can get an infinite number of points on that normal distribution curve. It could be the infinite. I just want to randomly get a 4 anywhere. All right. So I will specify the mean value. Standard deviation is 1, mean is 10. So you can get 4 points. All right. So those 4 points will be get from normal distribution. Now think about this. It looks like those four points exactly similar to 10, right or left. All right, and let's do it again. Now you can see the numbers totally change, but still around the 10. What do you mean by that? It means that firstly, it's a randomly picked number. So every time you run this, the number will be different. It's randomly picked different numbers. All right. But those numbers, it looks like the trend is similar. There are around 10s also. All right. And what exactly happens behind? Now let's draw here. Now remember, mean value equals 10 and the standard deviation equals 1. It's very perfectly spiked. Now think about it. Mean value is so large, it's 10. Standard deviation means error, only 1. That means most of the case will be concentrated in the 10 also. All right, that means like the students will get a final score. All right, most of the students like say 80% or 85. Mean value 25%. The standard deviation only 1 point. That means what? That means error is only 1. Most of the students in around the 85 also. All right. So the general shape will be like this. In our case, is 10. All right. Standard deviation equals 1. That means the shape will be like this. right? Mean value equals most likely 10. The standard deviation, that means the spread out only equals 1, 10 times of that. Now, on this normal, highly spiked normal distribution, you randomly pick out any 4 points. See what happens here. Let's see. I want to get this points, this points, this points, this point randomly. All right, blind your eyes and get them. Now, even randomly, those 4 numbers, you can see most of the points. Look at this, will be around 10, around 10. All right, this side is smaller than 10, this side larger than 10. Right? Okay. Now, say randomly, let's do again. Let's say I pick those 4 points, blue color. Those 4 points. Now look at this blue points. Their range also around 10 also. Right? Now it's very different if I give you say it's like this. All right. So in this case, you randomly select the 4 points, the value will be very, very large. All right, very large, because you can imagine that. Right? If the 4 points here, right, will be very different from the points over here because the value of the spread are so large. All right. So it highly depends on the parameters. All right. Okay, now sometimes you probably say this when for the random pick the numbers, right? Every time I run random, they give me different numbers. That's understandable because they randomly select the 4 numbers. So every time I run random, definitely the points will be different. So however, for example, I want to randomly select the 4 numbers, but I also want my students with, of course, like if you directly run this, I believe everybody in your class, we will get the 4 different points. Everyone number will be different because it's computed randomly. Now the question that I want a whole class randomly pick 4 numbers, but all of us, the 4 numbers are the same. So in that case, you need to specify in the generator of the random number, you need to tell the computer in what order. All right, this order is totally, you don't need to understand what it means here. It simply means you just tell computer with randomly 4 numbers, but everybody should get the same. Every time I should get the same. All right, so in that case, you need to set seed. 5, there's no meaning. You can see 5, 10, 500, 5 million, negative 10, whatever. Oh, sorry, negative probably not, just positive numbers. Whatever number, this number is no real meaning. It simply means that all of the randomness, whenever you, how many run you run this, the randomness, the sampling, the points, they're the same. All right, no matter how many times you do this. So just specify the sequence, specify the way the computer generates random number. That's it. It doesn't matter what the number it is. It could be used 5 or 56, whatever. Set seed. All right, now let's do it again. Hey, let's run this. This is a mean value 30 and a standard deviation equals 2. Again, this is still very spiked. Let's put in 4 numbers. All right, so let's run this. You type 4, you type X, right? Type the X. See, X is here. There are, of course, those numbers are around 30. All right, and as those more standard deviation. Now let's run it again. Let's run again. You need to run this. And then run again. You see what happens here? This number exactly located here. And this number, they are the same. All right. But every time you need to run the set seed. All right, let's do it again. Or you probably want to delete X. This is useless. Right, let's set this and the normal run this, you get those numbers. All right, and you do it again. You see, they're exactly the same. All right, you do it again. See, they're the same. Now, if you delete that, let's become notation, right? That means the computer will not exercise this. Let's run this. Okay, run again. Say the number will be different because you randomly pick different numbers. All right, that's it. All right, so what I'm gonna do here, I want to the function is that I want to simulate 1,000 values from the same distribution. That means I specify distribution, for example, like a normal distribution. I want to get 1,000 points from the normal distribution, from the curve, randomly. All right, so that's probably the easiest way. For example, I say I want to generate a large number of data, and the data should be follow some statistical distribution. All right, that's probably the quickest way. All right. You want to set a 6, you can see 5 or 50, whatever, like I said. And you want to spend number distribution, you want to get 1,000 points. Those points will follow the mean value standard deviation. All right, so let's do this. We need to give a name X because I need to use the X to refer to X to perform some analysis, right? You can see all the 1,000 numbers here. All right. All right. And the head and the history. Head simply means first few rows observation. You know, sometimes the data is very large, right? There could be 1,000 data. You don't want to display all of them. You just want to check if the first 6 rows, that's it. All right, let's see here, right? This is 1, 2, 3, 4, 5, 6. Usually the head function will give you first 6 observations. All right. Now, but sometimes the head you can specify how many. For example, the default is by default is 6 observations. You can see I want to look the first 10. They will give you first 10 of them. All right, there's an index here 1, 10 because of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and let's do this. All right. History simply means historical. That means the probability frequency graph it'll show here. You see, most of them are following the 30. Right. This is a frequency. I think it's kind of like 200 points around the 30. Like 28 to 32 is around 150. So most of the area is around 28 to 32. Nearly the, our average is 30. Right. And it looks like normal distribution. All right. So this is a histogram. So you basically use the function hist, H-I-S-T. Now, so far, you don't need to specify any packages, install any packages, because those functions are very basic mathematical functions. Like in Excel, I think there is a similar function in Excel too. So they're very basic mathematical, so you don't need to download any normal packages. But in the future, when you download, particularly, you want to do more complex analysis and the data visualization. All right, I give you 2 minutes to see if any questions. Okay, and let me close this. And there's a lab 2. And the lab 2 also upload to the Blackboard, all right? I'm not sure if I can finish all of them today. If I can, I will move to the next week, right? So yours progress still on the module 2. And our assignment, I will give assignment only based upon the points I covered, all right? For example, if I didn't finish this assignment, this file today, I will not give assignment based on this file, all right? Okay, now let's look at here. Now, okay, very interesting thing. Now this one is more down to earth, more real, a real exercise or using the real data. Firstly, when you open a script, all right, I upload it, you first encounter the first command, setwd. This one is very useful. You want to be careful here. This one is simply specify where your data saved. All right. Now, for example, my data is saved here. Let's see. For example, this is on my computer. All right, on my computer, I open couple folders, and this all my class folders is here. My materials, the teaching materials here, and my data is here. For example, the data I'm going to use today is let me see. Oh, data is not here. Data here, yeah, default fin.csv, right? You want to put the data and the script in the same folder, and the path you can write here, right? Is f new folder to 22 for 4220 materials. My definitely is a little bit this will be tedious, not quite good. You basically want a simple folder, 1 or 2 layers will be more than enough, right? So in that case, you can easy to specify the path, right? So, okay, you specify here. Now let's go back to so here, all right, you want to set way simply means you want to tell the computer where this file is saved. All right, exactly follow the the past positions, right? You want to make it pay attention to those signs, right? The column sign and slash, slash, right? Something like that. And even there's a white space, you want to keep the space there. Exactly follow that, right? The name. Now, definitely this is my habit, right? Materials, you don't need to do this, right? You want to the last layer, the better. Right? Last folder, the better. Definitely do want to give this as a where to give some space. It's up to you, the name you want to name your folder. And now you want to read the data because the data is .csv. So the R give you very easy to use functions such as read.csv. And this is CSV's file name. All right. And because when you read them, you definitely need to convert this data to our R Studio environment because you want to perform analysis in the software. And you want to give a name. The name, it could be DF data, default data, right? You can do whatever, you can say my data, whatever, name, Jackie, name whatever you want, right? And let's run this first. You can see here on this this XY is what the intermediate value when we perform the first file, right? It's stored here, the present, what you get. All right, let's write this. Okay, so now you can see there's a new data come. This is a truly data frame, right? There's index, employed, bank balance, annual salary, default. Those are column name, all right? And those are name, the value attributes, right? The integers, all right? Numerical, integer. I would like to say they're pretty similar. Integer and numerical, both of them belongs to the numbers. That's it. Although this is integer number, this is a numerical number, right? That's it. But they're similar, right? Okay, so but when you do analysis, you want to be careful because in the next step we're going to tackle with this. Those numbers probably have a different meaning because if you look the bank balance, this probably corresponding to different person or whatever. The bank balance is highly variation, right? Sometimes some people more, some people less, some people zero, right? There's a balance. There are annual salaries. All right, there's annual salaries. And okay, perfect. So annual salaries, and those are particular real number because you can see they have a decimal points, right? 0.68. This is decimal points, numerical number. But the other variables, their numbers probably have a different meaning. Like this, employed 10. It doesn't mean that one means one job, one position, or one what, or zero. So you can see this one simply means logic operation. One means employed. 0 means not employed. But the question here is that the number is an integer. How can we let the computer know what we mean to? Employment or not? It's a binary decisions, right? We'll talk about later on. This is index. That means the order of the claimant's data, right? The first claimant, second claimant, third claimant. There's also another index. This index simply means the R Studio give to you automatically number of rows. All right. So, although it looks like they're exactly the same, but sometimes different. For example, if you delete this data, if you delete the first claimants, the first person's data, you want to delete all of them. You want to delete them. So this definitely the index equals to 4 here will be disappear because this row will be disappear, the claimant number. However, this number is still there. This is automatically count how many numbers for all of the rows. And this column is by no means equals to this column. This column is defined by your own self, right? The order of the clients, that's it. Okay, so, and again, so default, so 0, 0, most likely there's no default, right? So default is a rare case. So that's why, well, if you carefully look at those, go all the way down, all right? You can't find any person default. All of them are 0, right? There's a 10,000 data, but actually definitely there's some people default. This is 1, that means 1, but you can't find them because there's so many data. All right. So that's why for such a lot of data, you can't use this for traditional user naked eyes or hands to do this. All right. Okay, so this data frame, and now sometimes you want to make all of the data, the attributes not a number anymore, but become the characters. So you can do the right, or sometimes for some weird case, it doesn't matter. Right. This is an str. Is basically display all attributes. Sometimes I don't think this is used necessary because this is from their web materials. I don't think this is necessary because you already hear from the data from here you can clearly see all of the values here and their attributes, right? So you basically probably don't need the str to look into attributes of the data because you can find it here. All right, you just click here the arrows. All right, and you will click the data name. It will be show the data here. All right. And again, so the head and tail will specify the first 6 and then last 6 observations here. Now, what is the usage of that? Sometimes I simply want to look at the data, right? That there's a millions of the rows there. I want to look at the column name. It's clearly shown here. I want to look into if the data, the number is reasonable. When I say here, the bank balance, annual salary looks reasonable, and the default all 1010. Okay, so that sounds okay. All right. And if you want to know how many the data observation, you want to look at the n number of rows because each row is each client observations. All right, so you can write down here. There's a 10,000 exactly, and sometimes because this is the data file named DF data, right? And the name here, and you want to specify the first row and the third column. This is similar to matrix. So now remember here, this data is not a matrix, although it looks like a matrix. There's many rows and there's many columns, but the attributes is data frame. All right, but you can specify the elements by your own self, like a matrix. All right, like here, this one represents the first column, first row, third column, right? It is 8,754. Let's look at here. First row, third column. First row, third column. This is third column. 1, 2, 3, third column, right here. Right. And this one is simply want to grab a subset data. Subset data simply means I want to 1 to 5 rows and 3 to 4 columns. So what exactly happens here? 1 to 5 rows. That means first 5 rows. 3 to 4 columns. Sorry, my bad memory. So 3 to 4 columns, right? 3 to 4, 1, 2, 3, 4. That means you want this 2 columns, but the first 5 rows. All right. So see what you get here. Right, exactly. All right. So those are very, the frequent, the data manipulation, and I think this is also very reasonable and straightforward. And this one simply you want only the first row, but you want all the columns. So you want to leave the columns. You didn't even specify any column range because you want all of them. All right. And this 1, comma. All right. We can see they give you all the data in the first rows. All right. But sometimes you want to look into the specified which column. And so it's like a second column, but you want to look at the first 6 observation for second column. All right. Here. Like this. Oh, sorry, this is my bad. Yes, that's right. The second column, right? Second column is here, employed or not. All right. But I don't think there's any, real meaningful practice here. But it just demonstrated, your data, flexibility on your data manipulation skill sets, right? So head means the first 6 observation for the second column. You want to see the second column. And sometimes you want to sum up all of the second column. All right. Now, this one has a real meaning. They give you 7,056. What exactly means here? Look at the second column. Second column means employed. If 1 is called employed. If 0 means unemployed. So most likely people think about employed and unemployed. Which one is more? It's hard to say, right? It depends on your position, right? 0, 1, 0, 1, 0, 1. It's hard to say. All right. So let's say if you sum it together, the number will represent how many observation here is employed. All right. So looks this is going to be 7,000 people employed. And how many observation we have here? We have a 10,000. Right. We have a 10,000. So it's around like 70% of people employed here. All right. Okay. And so the mean value. Yeah, I don't think this one is quite meaningful here. You basically delete that. I can't find any real meaning for this operations. And okay, this one is interesting. Table is a very powerful function here. Table is simply want to summarize the probability distribution. Now let's look at it here. So I want to look into the employee. This is another way to specify which column. Now you have already DEF data you specify, right? Since this is a data frame format, so you can specify, then there's a column name there, employment. You don't need to, there's another way to specify the second column. That means you want to use the $ employed, put the column name, variable name there. So they will means the computer know that you are talking about the second column. All right. You want to summarize here. Let's use the table. All right. So what you can hear, the table will summarize the distribution. Let's say 1, 7,056, that means people employed, and 0 means people unemployed. And similar, you can do the trick for the default or not, right, to calculate distribution. All right. Okay. And so in the next, I want to do a little trick here. Probably we want to today stop at this couple lines here. I want to talk about a very important concept. It's so-called factors. Now, for example, why I want to simulate some values by sampling 10 values between 1 and 5. All right, between 1 and 5. Now, what does that mean here? So let's say I have a 1, 2, 3, 4, 5. All right, I simply want to get 10 data points from the 5 value. Now, randomly, you probably is aware, how can I get 10 data from 5 data points? That's a very powerful tool when you analyze any data size. Now, sometimes the sample is very small and I want to enlarge the size. For example, I want to look into I want to look into some the efficiency of a drug. All right, the treated patients probably only hundreds of them use these drugs, very small. But I want to estimate how this drug usage for billions of people, the whole earth. Sometimes the data points very small, but I want to conclude some statistical, probability for large sample size. That's the best way. So if we only have a 1, 2, 3, 4, 5 possible chances, I can say get 10 points. All right, say 1, 1, 1, 2, 5, 4, 3, 3, 3, 2. So something like that. You can see this is 10 numbers. All right, 10 numbers, and I randomly write them, and all of the elements only composed from a 1 to 5. So my sample size increased to 10 points, data points. All right, this is very similar to, for example, in the probably in the high school, we play some games like this, right? When teacher talk about this, say, I have a 5 balls in the bag, right? The 5 balls. The balls have a index with each number, right? The ball, 1 ball, 2, the ball, 1 ball number 2, ball number 3. There's a number stick on the balls. You take the ball from the package and you put them back. All right, and then you blindly take a second time and you put them back. You can do this many times as you want, but there are only 5 balls in the package. All right, so that's the case. If I put 1 ball and I put them back and I grab again, repeat it 10 times, you will have a 10 numbers. You understand the game here? That's the trick, that how can I use the limited sample to regenerate a large sample size? All right. Okay, perfect. Now let's so it's here. Again, so I set seed 155. The reason is that if you do this action again, definitely the number will be different because you blindly, right? You stretch your arms and hands to grab the ball and put them back. And for 10 times, you get 10 numbers. All right. And then you repeat this action, of course, the number will be different. It's very randomly. So that's why if you want to ensure you randomly pick the 10 numbers the same, you need to set a seed. All right. 155 is it is a random number. You can put you can put the 15, whatever. I told you this number it doesn't matter. It's meaningless. You can put any number there. Right. This one only control, but ensure your randomness are same. All right. So for example, that means sample function, this function, I only have a 1 to 5 values. I want to get 10 data points. Replace equals true. That's the must be. You need to replace. When I say replace, that means you grab the ball and you put them back. That is a replace. All right. Now think about this. You grab the ball from the back, but you never put them back. What happens? You only can get 5 points. You can't get 6 or 7 more than that because you don't put them back. All right. So that's a replace equals true. Now look at this. And to look at the X, 152532, something like that. It's very expected. Now, if you do it again, I'm pretty sure the number will be the same. Oh, sorry, it's different. It's something wrong with here. It's all disappeared. I need to. That's really weird. Sorry about that. I think that this previous, yeah, let me see. Yeah, okay, go back. Sorry about that. Now let's go back. Yeah. All right. So that's what I did, stupidly delete all of them. So this here, right? Let's do it again. So let's redo here, run. Now X equals to 522115, right? And let's run again. Right, the same, because you can see the order, they're the same, right? 5221, 5221, they're the same. Now, if you don't specify this, and you do it again, 145, the sequence will be totally changed, right? The value will be changed. Okay. All right, that's it. So I just to talk about the sample functions here, and I will leave the next week to talk about the factor. You want to pay attention to this next command of factor. I will leave to the next class to discuss that. All right, factor, because I think this is a very another important milestone there. So if I give you the homework today, all right, so on the Sunday, probably Sunday, but I'll officially announce it on Monday. All right, so give you 10 days, and the homework will be only relevant to those codes. All right, and the purpose one we talk about. I will not talk about the rest of them. All right, so that's all for today's classes. Thank you for attending. And if you have any questions. Okay, perfect. Now in that case, we can leave. Thank you. I will post the video on the Blackboard. You too. Bye-bye. Have a weekend. You too. Bye-bye.